You're invited to our
On Par SePARation Party! To make raisin yeast water, first add raisins to a jar. Next, add distilled water to the raisins in the jar. Cap the jar. Shake it and set aside to start fermenting process. Continue the process for 7 to 9 days, shaking and opening the jar each day until all the raisins rise to the top. Lastly, strain to remove all raisins from the yeast water.
For this experiment, we replicated the setup from the distillation lab we did in class with the condenser. We had the hot plate initially set at 240 degrees Celsius. Some molecules started down the condenser, but we thought the yeast water was boiling too much, so we decreased the temperature. The substance cooled by the water surrounding the middle tube of the condenser traveled downward to the collecting beaker. The first droplet was expected to be mostly ethanol because of the lower boiling point of ethanol. Since the droplet did not seem to have many hydrogen bonds like water would, we were very hopeful because the droplets didn't stick together. However, on the trials of the first day, all of our efforts failed.
After the devastating disappointment from the first trial, we altered our procedure by trying distillation low and slow. Therefore, our initial temperature was about 150 degrees Celsius, and we never let the temperature go above 200 degrees Celsius. We noticed that the ethanol did not have enough energy to travel through the rubber stopper, and doing so, we raised the temperature, causing water molecules to condense instead. However, when trying to ignite the ethanol, disappointment struck again.
So sad.
Following 2 failed trials, we spiritually communicated with the chem gods, aka talked to Jason Jewick. We took advice of starting at 175 degrees Celsius and increasing in 25 degrees Celsius increments, going no higher than 250 degrees Celsius. When the yeast water looked like it was simmering too vigorously, we turned the temperature down gradually to 175 degrees Celsius. And at last, after days of work and hours of trials, we finally gathered enough ethanol to start a small fire.
We made a latte, which includes milk and coffee particles. We poured some into a container and then added vinegar, which caused curds or casein protein to coagulate. Then we filtered the vinegar coffee through a cloth filter twice and set the container outside for evaporation.
plastic lid we placed on the container caught clear droplets from the filtered coffee. When we removed the lid and sprinkled baking soda on the droplets, there was fizzing and bubbles produced, so we knew what evaporated was acidic. We put the container back outside, wrapping a cloth over it so it would evaporate, but nothing would get inside. A month later, we end with what we assume is some sour coffee.
For the last part of our project, we went in for a tour at the Hyperion Water Reclamation Plant in El Segundo. Alan Rodriguez, our amazing tour guide, first gave a brief overview of the entire plant, describing the water from schools, works, and homes that go through the water reclamation process.
The fifth largest water reclamation plant in the world. Okay, 700 people work here. We serve over 4 million residents in the city of LA. Okay. What you guys are gonna see today is this right here. So this is where you live.
Inside the building, there was a topographic model of the entire LA County. Because the water plant is on lower ground, gravity helps to guide the wastewater from high ground toward the plant at a rate of 2 feet per second. From low to high ground, the pump is needed.
After the overview, we went into a truck for the tour of the plant. He explained how the treatment plant employs its own workers, including painters, carpenters, and mechanics, to operate. Next, we learned about the foul odor preventing structures on the left side. Because of the residential areas nearby as well as environmental regulations, it is necessary for the treatment plant to scrub the air with bleach, or NaOCl, sodium hypochlorite.
Next, we toured the dome-shaped centrifuge. Close to the centrifuge, there was an eye and body wash. Alan described safety standards by the Occupational Safety and Health Administration and strictly cautioned us to make sure that safety was our priority, since industrial chemical coagulants were being used. For the coagulation process in the centrifuge, chemicals such as NaOH, ferrous chloride, FeCl2, and ferric chloride, FeCl3, are used. The chemical coagulants make the organic compounds such as food and human waste stick together, separating them from the water. The platforms that you see here further separate the fats, oils, and grease, which float to the top from the coagulation process.
In another section of the plant, there is a final clarifier, where the water is sent to a site a little like a swamp. Microbes eat the particulates remaining in water, then sink to the bottom as they become heavier. They are sent to the center of the circle and are reused when they go back into the digester. When we looked at the underground system, we could smell the slight mustiness, which would have been worse without the bleach.
Leftover inorganic waste is loaded into trucks, weighed, and sent to landfills. For the Hyperion Water Treatment Plant, accountability is everything.
Thank you to our tour guide, Alan Rodriguez, for this amazing tour. Now, let's take time to admire the beautiful birds.